So this is a worked example on how to graph a quadratic function. In the worksheet, I gave a list of 4 things that we can sort of look for before we actually graph a quadratic. Now, you don't always need all 4 of them. You can kind of like get some of them and figure out the rest of the information, but if you see a graphing question for any quadratic, if you just start solving these 4 things, the picture will become a lot clearer on what we're actually trying to do. And so I think this is a great starting point. And if you're on item 3 of 4 and you think, okay, I know what the graph looks like, then go ahead. But just as an example, I'm going to do all 4 items for this specific function, and then we're going to draw a graph of it. So let's see, the first one that I put in was a vertex. So to solve the vertex, we use a different formula depending on the form that the function is in. Our function is in standard form, which makes the vertex easier. If we had general form, we could either use the general form formula, or we could complete the square, convert to standard form, and then find the vertex, whichever method works best for you. But we already have our function in standard form, so we can go ahead and identify the vertex as the point h comma k. So what's important to keep in mind here is if we have the vertex and we're looking for h comma k, you want to be very careful with how we define h, because remember, standard form is the following. So it's mean x. In the standard form formula, h is already negative. So it's very easy to mess up and mark the h as the wrong sign. So in our original function, we have x minus 1 squared. And so our h value is simply 1. It is not negative 1, it is simply 1. And so let's see what that looks like. We are going to have open parentheses 1 comma k, which is negative 1. So our vertex in this case is 1 comma negative 1 in the h comma k equation, right? So we have h is here and k is here. And so that's how we identified h comma k. Now, the other thing that I put down is if the parabola is opening up or down. So we'll say parabola direction. And to identify this, we're going to look at specifically the a value of the quadratic. And the good thing about this is the a value is the same whether or not we're in general or standard form. For our specific quadratic, the a value is 1, so there would be a mystery a value right up here. But because it's just 1 and the a value is positive, the parabola is opening upward. So the direction is opens upward. It can also be useful to note if it's stretched at all. You don't exactly have to if you're filling in the rest of the points, but if, for example, the parabola had, say, a 5 in front of it, then this specific parabola would be very stretched out. And if you had, say, for example, a fraction, like if you had 1/5 instead, then it's going to be very wide. It's going to open very wide, but it's still going to be upward and downward based on the sign. So our sign is positive, so we open upward. Oops, I did not mean to get rid of our parenthesis. How do I get rid of the 5? There we go. Okay, so moving on to the 0. Actually, let's say the 0 is for last. Let's do the x-intercept, or let's do the y-intercept first, because that'll be easier. So for y-intercept, we want to take advantage of this idea that any point that lies on the y-axis has an x value of 0. If I draw a quick picture, if I was graphing an equation and I had a point that was right here, I may not know what that y value is going to be, but that x value has to be 0. Because if I had an x value of, say, 1, then that point is going to be moved 1 in the x direction and no longer be touching the y-axis. So we can solve by setting every instance of x equal to 0 and seeing what we get. So in our original equation, we can set this up as y equals, but every time I would see an x, I'm going to instead write 0. So we'd have 0 minus 1 squared, and we actually only have one instance of x in this case. And so if I simplify this out, I'm getting negative 1 squared minus 1. When I square a negative 1, that turns into positive 1, and I am subtracting off 1, and so our y-intercept is at 0. So this function will cross the y-intercept at 0, and the x value is also 0, so it's actually going to cross at the origin. That's some useful information there. So let's move on next to the zeros. And when I say the zeros, this is generally referring to just the x-intercepts as well. And so we can use the same logic again, right? If I have a graph and I want to know what points are going to lie on the x-axis, I know that the y value of all of those coordinates has to be equal to 0. And so we can set y in our equation equal to 0. And so what we're trying to solve, let me write zeros, keep it general, but this is the x-intercepts also. We're going to set 0 equals x minus 1 squared minus 1. Now, this might not look too bad. However, solving quadratics, or solving for x-intercepts is much more involved than solving for y-intercepts. And so a couple of methods we could use, I guess like the big one is factoring. You can also use the quadratic formula if you have that memorized. If you had access to technology, you could use a calculator, but in this course we're not allowed to use calculators, so we're not going to be doing that. But I'm going to try and factor this function. Now, to factor, we actually want to be in general form. So we use completing the square to transfer from general form into standard form, but we can actually just expand the equation to convert from standard form to general form. So I'm going to expand this specific binomial term. So it's going to be x times x, which is x squared. Then I have negative 1 times x. Oops, not my eraser. Negative 1 times x, but I'm doing that twice because it's a binomial. Negative 1 times x, and then negative 1 squared is going to be positive 1. Now we can, let me draw that plus sign a little bit better, but now we can go through and combine like terms. So the two minus 1 x values can get combined into, whoops, I keep hitting the eraser button on accident, into negative 2x plus 1. And then I actually realize that we also just want to bring down the minus 1 on the end. And so now we can continue to combine like terms, and we see that these plus 1 and minus 1 terms will cancel. And so for that, we will get x squared minus 2x. And from this point, if we're just factoring, I can actually see that both terms share an x value. So I'm going to factor out an x value. Put my doc away. X times x minus 2. And so now that I've factored, we can use the idea that I can solve anything for, if I have this whole equation set to 0, right, and I'm multiplying all my terms, we're going to use this idea that anything multiplied by 0 is 0. This now means we can analyze each term individually. So we can analyze this individually and this x individually, solve those individual portions equal to 0, and we will get zeros for the whole function. So I say, well, what is x minus 2 equal to 0 going to solve? Well, with some pretty simple algebra, we can see that x equals 2 in this case. So 2 is a 0 for our function. Even simpler, if I just directly set x equal to 0, I don't even need to solve. I just know that x equals 0 is, again, a 0 of our function. So if we go through and we look at everything that we have solved here, we can now start to put together a picture of this function. So let's review. We have a vertex of 1 comma negative 1. We know our parabola opens upward. we have a y-intercept of 0, and we have 2 roots at 0 and 2. So let's go ahead and put all this information on a graph and then fill in the rest of the information. So, can I draw a straight line here? There we go. Okay, and let's draw a horizontal line here. Okay. Alright, and so let's add a few tick marks in each direction. Alright, so let's start with the vertex. The vertex is +1, -1. So I know the vertex is going to be right here. And let's now fill in the information for the zeros. So the information for the zeros and the y-intercept in this case kind of overlap because we have a 0 at x equals 0 and a y-intercept at y equals 0. But I do know that I have an intercept for both x and y at the origin. And then I have another x-intercept at x equals 2. So I can fill in a point right here. Now we also know that the parabola opens upward, so we can fill in the rest of this information by drawing, not perfectly, a parabola stemming out from the vertex. And that is sort of how we can go about solving or graphing a quadratic. And like I said, you may be thinking, okay, that is a lot of information, that's a lot of things we need to solve to do a quadratic. But keep in mind, once you get good at this, you don't always need all 4 bits of information. Like, for example, if I just solved this x equals 0 term, I can kind of understand that my y-intercept is also going to be 0, right? But if you are a beginner, if you're just starting out at this, and I know a lot of you are, I recommend just trying to hit all 4 topics and then aggregate the information to drawing a graph. And I think that'll help you a lot, and as you get better, you can sort of start taking shortcuts when you feel that you are able to. But that is a worked example on how to graph a quadratic. If you have further questions, you can submit a question to me on my website at romansimkins.com/pal/asking a question or whatever the homepage is. But I wish you good luck on the rest of this worksheet.